Hello guys, welcome back to another video of my series, game making a game engine with Rust. So in this video, we will be explaining the event system that we are using in this game engine. So first, let's just explain what is an event. So in programming, an event is an action or, or like an occurrence that software program recognizes and can respond to. Uh, these are often triggered by user interaction, such as like clicking a button, typing keyboard, closing a window, or even system-generated response like generating emails after a subscription button has been clicked. So that what event is, and why do we need an event system? So while we're making a game engine, there will be multiple times when we need to track certain events, such as, like I said, mouse click, then mouse movement, keyboard key press, key down. Those events are need to be tracked. So due to that, we would be requiring a extensive event system. Now, every event system has three properties: an event source, an event listener, and an event handler. Event source is basically from where an event is generated. So that can be your monitor, your screen, or maybe your window, or maybe the application itself, or like particular property of application, like uh, clicking on a button, or some random events that can be generated in the background, like cron, that can be triggered through cron or something, right? Then there is event listeners. Event listeners is basically, you can say, like a background, like a polling concept that basically listens to all the events that has been generated by event source. Event handlers is basically those functions that are attached to the event listeners, and they are called by the event listeners whenever that particular event is called. Now, there can be two different ways we can introduce a event listener and this whole system, event source and event handlers. One is way of dispatching, another way is of event queue. Dispatching is an immediate action. So let's say you click something on the screen, there is a window on the screen, and you can click something on the screen and it will immediately open it. This is what event dispatcher is. Like, it has an on emit. If you see, like, I'll go through the code then. uh, if you see, like, this is the event dispatcher. This will have an add handler where we can add a callback. It will have a dispatch which will dynamically take an event, and it will like call the, like, it will check if that particular handler is capable to handle this event. If it is, then we will call the, like, handler. Yeah, basically these are the only two functions that you required for the event dispatcher. We don't need anything else, to be honest. So that is the one. Okay, so like I said, we would only need two functions. That is a add handler, which will add a callback, and dispatch, that will handle everything. And dispatch, which will handle, like, whenever our event is there, it will handle accordingly. So it will check if the handler is capable, and if it is capable, the handler is capable of handling that particular event, it will call that handler. That's what happening in this function actually. You guys can, if you guys are going through my GitHub, you guys can check out the test cases. So I have, like, added, like, all the possible edge cases in the test cases. For example, if it's a success, then what will happen if it is multiple success handlers, and so on. So I'll give you a small example what's happening. So let's say there is an event that is called a test event. Okay. You will see, this is, yeah, this is the test event implementation. This is the test event structure. What we are doing is, basically, we are creating an event dispatcher, and we are getting the event name, and we are adding a particular callback to this dispatcher in here. Uh, okay, I'll explain what we are doing. in here we are creating an atomic reference or an atomic reference counter for an atomic U8. Atomic U8 is basically an U8 which is wrapped around an like an arc or atomic layer. What it does is basically it's a threads of U8. So you cannot like once a particular thread is using this variable, other thread will not be able to use it because it's threads of like deadlock and stuff. Anyway, so what we are doing is we are fetching and adding one to this like particular U8. So we are basically incrementing it by one. This is the callback, and we are adding to this callback. Now, what we are doing, we are dispatching that event, like that test event, and we are expecting we are expecting that dispatch should succeed. Uh, like, don't mind my spelling. My spelling is really bad. Uh, yeah. Then we are checking that atomic counter should have become to one now, and that's what's happening. So if you check, if I run cargo run test, sorry, cargo test. I've been using Node.js, right? See, where's the success? Yeah, here you go. So it's okay. Now moving on to the next like event handler that we have, that is an event queue. Now event queue is like a superset of event dispatcher. It uses a event dispatchers or multiple event dispatchers, and what it does is basically uh, it has an emit and get events. So what you can do in event queue is that you can add multiple events to this queue, and you can wait for the next iteration of the event loop in order to get all this event and then call their handlers accordingly. So you will see we have initialization. This is basically a global event queue function. This is how we are creating a new event queue. What we are using is MPSC channels. These channels are threads of channels. They are sender and receiver. What they do is like the sender is basically from where you will be sending all the data, and receiver is the receiver. And internally they uses threads of mechanism to store and handle like all the data throughout. Okay. So emit. What emit does is basically uh, it basically takes an event and it's uses the sender to send the event to itself like this to the receiver end. And get events is basically iterates through all the so we will iterate through all the events that are present in the receiver, and we will like call their handlers accordingly. So we will check the events. If there is any event, we will push it to the events queue, and then we will like return this all the events as a result or like of this function. So I'll show you the implementation of the event queue, which is in the application.rs. So in application.rs, what we are doing is we have an infinite loop, and inside it we have initialized an event queue. Now in this event queue, on every iteration, we are getting all the events that are present in the loop, in the queue, and then we are calling their handlers, basically using a dispatcher. So that's what basically happening. Now we will show the code that is we are using for Sandbox. So in Sandbox, we have multiple handlers present. One is handlers for the event with data, so it handles data events. There is another without data. There is one that has data in it, but at the end of the whole like the thread, it like enters a special event, which is an exit event. Now, application events is a part of a special event structure that I'll show you in some time later. But this is how it's working currently. So this is the first event. This is run before we have called like the event loop, and this is called through dispatch. Now once the dispatch has ended, the event loop starts, and the event loop is calling one by one. So the first event is the example data 1 4, then 2 5. Like basically it's incrementing, and yeah, basically after all of them, like I'll show you main database as well. Yeah, we have added this events with data, which basically after calling after calling the whole thing it will exit. So after calling the whole thing it has exited. uh, so that's how it's working. Hope you like it, and yeah.